Hi everyone. So next topic is motion of charged particle in both electric and magnetic field. So as I told you before, like I have given you one small hint that so if there is an electric field also, then there will be two forces acting on that charged particle, both electric Lorentz force and magnetic Lorentz force. But electric Lorentz force is nothing but it's Coulomb force. Okay. So we in some places I have seen that it is also known as electric Lorentz force, but it is actually Coulomb force. That we all know that, right? F is equal to QE is a Coulomb force, no doubt in that, right? All right. So let's talk about the combined electric and magnetic force on a charged particle when it moves or in an electric and magnetic field. All right. So here I have given one magnetic field. So what is the direction of this magnetic field? It is into the paper, inwards, right? So that is why the direction, which is perpendicular. I mean perpendicular to this plane. All right. So next is, so here one electric field source is also given. So this is the electric field source where positive and negative charges, I mean charge streams are given here. So or you can simply draw the electric field lines without showing positive and negative, but it is very clear, it is very evident from the figure or the arrows that the arrows are going like this. So from positive to negative, no doubt in that. Apparently there is no doubt in this. Okay, so I can say that one thing it is very clear. Here both electric and magnetic fields are acting and the charge is moving in this direction. Then the force will act, look at this, all of you listen. So the velocity vector in this direction and this one, I mean magnetic field in this direction, inside. So what will be the QVB? QVB force will be in this direction. You got me? Which is perpendicular to both velocity and magnetic field. You look at that, you can check the direction. V cross B. It is three-dimensional, it is difficult to understand. But anyways, if I consider this as magnetic field and this will be the direction of QVB, force. So the same idea we can use it here. So I'll use it the V cross B. Look at this. Oh, sorry. This is one V cross B. This one in this direction. Alright. So the direction actually, so it is three-dimensional, that is why, or you can, or think about this. So the screw rule, we can check the screw rule, look at this. In that direction. Okay. So again, which is equal to F is equal to QE. That is what is electric field, I mean electric Lorentz force or Coulomb's force direction. Coulomb's force direction is QE. So where it starts from positive to negative, Q into E. Okay, the direction of that force is Coulomb's force is in the direction of electric field only. Alright. So this is what is the thing. And one more thing you have to note that. So look at this. Here QVB, the magnetic Lorentz force is direct, I mean it is in the opposite direction of QE. So suppose in some occasions, suppose you consider F is equal to Q, we know the equation F is equal to QE plus Q into V cross B. It is clear. Or here V cross B is V into B into 90, sin 90, which is equal to Q into E plus QVB. Alright. So now I am going to ask you something. If these two forces are in the opposite directions, so if they are equal in nature, then what will be the value? So what will happen? F will be equal to 0. They are equal and, I mean suppose if they are equal and opposite, then what will be the value? F is equal to 0. And then I can say that QE will be equal to QVB. Q would cancel. What is V? V is equal to E divided by B. So we call it as E0. V0 is equal to Q E divided by B. Look at this, E divided by B. So this thing we will study in detail in electromagnetic waves. Okay, in electromagnetic waves also we have to check this because you must have seen C is equal to E by B. E0 by V0. This is exactly. Okay, the peak values. So this is actually, we will discuss in the case of electromagnetic waves in detail. But anyways, you keep in your mind, this is very important. V0 is equal to E by B. So here velocity deflection, we have given three particular cases. It is easy only to understand. The idea is very simple, right? You look at this, the idea is very simple. You can write a lot of things about this. So V0 is equal to E by B. When it is V0 is like only when F is equal to 0. So this V0 in this case it moves in straight line. It moves in straight line. Keep in your mind that. Okay. So one like we are going to discuss first case. V is greater than V0. Suppose V is the actual velocity is greater than V0, that is this value, and when the force is equal to 0, then the charged particle deflects in the direction of Lorentz force. Charged particle would deflect in the direction of Lorentz force. Okay. Second one, if V is less than V0, then charged particle will deflect in the direction of QE. Okay. First one, if it is greater, then it will deflect in the direction of QEB, otherwise in the direction of QE, Coulomb's force. And if V is equal to V0, that is in this case, that is there is no deflection, it moves in straight line. It moves in straight line. Okay. So these are the cases. And now final topic, today we are going to discuss the final topic in the next video, that is cyclotron and cyclotron frequency, etc. Thank you.